So this will be a review of the Amazon Basics AA nickel metal hydride battery packs. So I'm going to do a review for two sets of batteries. The first set of battery of 32 I bought brand new out of the box, which I'll test now, and the second set will be batteries I've had for 3 years, and I'll show you how those perform. So this is the load tester I'm going to be using on the batteries. It'll discharge the batteries at a constant 2600 milliamps, which basically tests the nameplate rating on the battery. So this is the charger I'm using to charge my batteries, the EBL nickel metal hydride battery charger. I charge these. Once they're charged, I pull them off the charger and then I stick them on the discharger to see what their capacity is. So this is my setup with the discharger, the charger, and the holder for the battery. I've got some extra thick wire to reduce the voltage drop that the battery carries to get very accurate measurements, and this seems to work very well. So this is the discharger in action. So basically the bottom LEDs are used to set the cutoff voltage and the current, and then the top one is used to display the amp hour, the watt hour, and the average voltage during discharge. It's actually fairly simple to use. So here's my data from the test. If you look at the second column, the MAH or the milliamp hour column, all of those are displaying under 2600 milliamps, which is what the battery is rated for. If you look at the below capacity column, that's basically compared to the 2600 milliamp hours, which is rated for the battery. If you look on the side of the battery, it says it rates at 2600 milliamp hours. So a lot of these are falling between 12 and up to sometimes 28% lower capacity than it's actually rated for. So on average, these batteries are doing probably around 17% lower than what they're rated for. Now here's a great graphical representation. If you look at the arrow, that's the capacity of the battery line. That's where the battery should be performing to the top 2400 grain line. But the actual results, as you can see, all the batteries, they're far below the 2400. It looks like roughly about 2000 milliamp hours of capacity. So these things aren't performing what Amazon says they should. And I don't think for high current rated applications, these batteries are really worth it. Because you can see, obviously, with 32 batteries, which is a decent sample size, I can maybe see one or two not cutting the mustard. But all of these literally do not meet their rated current. Okay, for the next test setup, I thought, well, what if I take the 2600 milliamps down to 2000 milliamps and see how it performs? So I did that, and these are the results of that on the charger. It still did not meet specs, so I don't like these cells that much. So what's my thoughts on them? They're overrated. They're good for 2000 milliamp hours, but not 2400 milliamp hours. Okay, these batteries, a total of 16, were bought as a gift for a photographer, and we started noticing some failures on the batteries, and I just wanted to run them through a discharger to kind of determine what their state is and kind of compare that to what they should be. Here's the second time I bought these batteries. The first time was around 2017, so I'm going to give you a review of that date. So looking at what they're advertising for the first bullet point, the 2400 milliamps was disproving by the first set of tests I just did. And now if we look at the third bullet point, you can recharge them up to 100% capacity even after 3 years, and you'll have minimum power loss or capacity loss. Well, we'll show you here next that that's not true. Some of the cells experience up to 60% capacity loss, while most of them were probably in the 30% range. So after 3 years, it's nowhere near you can charge them up to 100% capacity. So these same 16 cells were put on a discharger, ran at 2400 milliamps, and as you can see, the ones in red produced failures. They wouldn't even discharge for any moment of time for 2600 milliamps. That occurred 5 times, so we have a failure rate of almost 32%, 31.25 to be exact. If you notice on the capacity side, their capacity has fallen between, some of them worst case 30%, some of them 60%, but it doesn't definitely stay up to nowhere near the 100% that's claimed. So for professional batteries, I wouldn't recommend those. However, if you want to just charge basic electronics and you don't care how many times you got to take them out and recharge them if they lose capacity, so on and so forth, these batteries aren't that bad. But for professional use, I'd buy something else.